Hey, I'm Zoran from Project SeaSense. We're creating a global community-powered network of ocean sensors. Today I'm going to show you how to DIY one of those sensor buoys yourself. Let's get started. Let's first take a look at what you need. A drill. I have an 8mm bit, a big ass bit, a pen. Extremely useful, so you can write your name on it and your phone number, so when it might get lost you can actually find it back. I forgot to do that on mine. And a small knife, so you can cut parts of the board open. And of course a measuring tool. Then this is the board, so this is the baby that's going to float and have the sensors cut through it. It's very simple. It's hardened here at the bottom, soft at the top, so it's very easy to cut a slit that you can put this thing through. You can use the drill to cut holes. Depending on the sensor, you either use the big one or the small one. And that's how we're going to prep it. After we prepped it, we can put the sensors through. Here I have a salinity sensor that we want to push through, right? So when I take the drill bit, just want to make sure that it's big enough. Well, that should work. This one is the turbidity sensor. You probably want to drill a little bit wider. It doesn't come too accurate, to be honest. This is temperature. That's probably the smaller one. And there's another smaller one. Now, once we have these things drilled in here, we need to get them into the box. The box is watertight, so nothing can come in, but we need all of these things to go in. How do we do that? Well, we take a drill, oops, and then we just drill holes in here. We put these guys through, and then when they are through, you can push this through. And then all these lines, all these connectors, all these boards end up inside the dry container, which you can close off. And then the next part we will handle in chapter 2, but not before. We put Velcro on the bottom of this, a few pieces here, 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 wherever you see fit. And then we will attach this here. What you will end up with is the board, the fin going through, and the sensors being pushed through here, and the connecting cables of the sensors going through holes in here. Well, that is it. I'll show you how to do it. The first thing you do after unpacking the board, and that's kind of the most important thing, my big lesson, is you write down projectseasense.org and your phone number, just in case it gets lost. My first prototype actually got lost at Markermeer. I was sailing happily, and then after an hour I looked back and it just wasn't there anymore. And people said, "Hey, you have GPS on board?" I said, "Yes, I have GPS, but it only logs locally. I didn't have the SIM card configured." So anyway, I also didn't write down my name or phone number, so it really got lost. So this is my second prototype that I have to build now. Anyway, but it's good because then I can show you how to do it. Let's get started. After writing down a name and a number, we flip it over to the other side, and then what I did is I looked at this guy. I figured the depth where this goes through 5 centimeters. At 5 centimeters, the width is 13 centimeters. So what I did is I just drew a line here, just in the middle, about here, I mean, it doesn't really matter, of 13 centimeters, because that's the slit where it needs to go through. I also marked where I want to put the sensors. The bigger salinity one goes here, the smaller one goes here, the temperature goes there, and the turbidity goes there, but feel free to throw it around. I don't think at this point it should matter. And then it's around cutting cutting. This one open. Drilling these guys. And make sure to just see if it fits snugly, because you don't want water to go through. Not that it really matters, but you want it to fit snugly so that the sensor is stable in these positions. Next up is the new line. What I did is just in the middle, I drew a line to the bottom, which from the end has the same distance as this line from the end, right? Then just drew that and then measured that this is a little bit longer, because at the top it's a bit wider, right, than here. I added a few centimeters, and that's basically this one. I already cut the bottom part. Now I'll cut here, and then I'll just hope they meet in the middle. Should be around, and otherwise, I mean, it's all soft, you can just ram it through. Cool. Yeah, now I'm just pushing the whole thing through. And there you have it. Bodyboard with a fin. This is what it looks like on the top. At the bottom, is it straight? Straight enough. Cool. Now, let's drill some holes. Great success. Only this is not a microplastics detector yet. It's more a microplastics generator. First sensors in. Look at him. Right? It's that easy. This is the part that goes into the box later on. So we have a sensor, we have a fin. Let's do the other three. So sensor number 2, I used I think a 5mm one so that it fits snugly. It's for the temperature sensor. So we have that guy as well. So it's 2 holes. Now we just need the other 2. So for this sensor, I did a 5mm hole from basically the bottom, because I want this to go all the way to the plastic barrier. So the bottom part's 5mm, and then the other one I will use the bigger one. So first I drilled from bottom to top, and now I'll go from top to bottom with a bigger drill, so that this guy ultimately can go in all the way, and then it's automatically stopped at the end by this hardened piece of plastic. Oh, and by the way, be very slow with drilling. Slow, careful, just take time, and if you fucked up, just drill another hole. So now you see the hole is bigger at the top and it's small at the bottom. So let's see if we can push this through. Wait, all that stuff, and then we're gonna push it through. There we go. Just need to push it a bit more. So as you can see with this prototype, we're measuring right at the surface. We probably want to do that at -1 meter at some point, but this guy's in. That guy's in, the other one I just pulled out, but that is in. So then we have 3. Let's do the 4th one. And for this last guy, the turbidity sensor, I just cut out the part where I want just this top part to go through, from the other side of course, but I can test it around here. So it's kind of the snugness that I want, so it's fixed. And now I need to, basically create a big asshole from the other side, so this whole thing can go down there and that it fits snugly. In order for it to be waterproof, because this out of the box is not waterproof, don't ask me why, it's probably from a washing machine or something. I use hot glue to just hot glue all of this, all of that, and especially this part of course where the water can just go in, and just put a whole bunch of it on it, and then just plug it through from the other side. So there we are. This is the big hole I made. Push the whole thing through. See on the other side, I mean, it's not the prettiest of holes, but it needs to go all the way through. This needs to be snugly behind it. I'll probably glue this part in so that it's really needs to come out, the whole sensor, and that there's no turbulent stuff happening here, so water can pass through clearly. I still need to get the whole thing out because I forgot to glue this guy from the inside. So I'll get it out, glue it, push it in, and then I'll probably glue it here as well. So now we want to get these things in here through a hole here, here, here. There's 4, so we need 4 of these. So we'll drill holes, 1, 2, 3, 4, and I can add 5, 6 later maybe. So let's start drilling. What I'm doing is I am taking this drill bit. It's I think 8 millimeters in this case, so it should fit, and I'll just need to widen it a little bit so it fits snugly. So we have a hole, and we push this thing through. Connect the other one on the other side. This. And make sure you twist it really well. You're doing. Twist it really well. So then it's waterproof if you put a right-sized cable through it. So make sure the cable is the right size. And then we do the other ones. And then it goes on top of here with our Velcros that we put underneath. And then, yeah, basically it's up to part 2 to connect everything. So, last one. So before we put the Velcro on, I'm gonna make sure it's not greasy. So just a bit of degreaser, whatever you have. So make sure that it sticks. Degrease. Cool, let's wait. And we stick the last one on. So Velcro, you might ask, is it sticky enough? I don't know. Last time around I had a full patch of Velcro and that was like super sticky, but now I do 5 patches. Let's see if that works. So we rip these off and we put it there. This guy. Okay, so we took it off. Let me stand up. Can I still stand up? Yeah, cool. There we are. So we put it around somewhere in the middle, maybe here. So around the middle, yeah, should be good. Press it on because this thing is not going to come off anytime soon. Pretty good. Pretty good, pretty good, pretty good. Pretty good, pretty good, pretty good. Okay, and now we're going to put these things through here, these as well. In order to do that, you need to carefully remove this cable from that connector so you can put it through that hole and then reconnect it. So this is on the inside, goes for this one, this one, this one, and the other one that is lying there, and then they're all inside. And then once we have that, we put the cover on. And then the only thing we need to do is install the brain here. So that's the microprocessor, connect everything, solder, add the GPS, etc. So stay tuned for that. We talked about the turbidity sensor, that it's waterproof on this side, but it's not on that side. It's probably because it goes into a washing machine like this, but we're going to put it into the water. So water might drop on the top. So what we're going to do is we're going to find every crack there is, every entrance of water, and we'll just flush it with glue. So glue we get from this beautiful device. It's a glue gun. Cost me probably 10 euros from AliExpress. Just turn it on and you pump glue. Does it work? Yeah, glue. Okay, let's get started. So yeah, plastered just to make sure there's nowhere that it can enter. Make sure, of course, that you don't hit the sensors because then the whole mission is failed. But I think this should do it, and I'll do some more when I connect it into the board. Yep. And I also recommend to take a picture before you take this baby off, because you need to plug it in the right way again after you put it through here. So let's see what we have. Turbidity. Yeah, it could be better, but I think this will do for now. This one also aligned in that way. That one and that one. So water can actually pass through. I think that's good. Water will come from here, so there's nothing in the way. It's just a little bit shallow, but that's something for the next prototype. And the other side is as follows. Lots of cables coming out, sure. Here they go in very nicely. And let's put this open. And come here. Just need to connect this guy. I need to connect this guy. This one here. And this one. So, if we put the cover on. Pull it up like this. This is quite working. I mean, it's not detaching, so I would say this is quite the way to do it. Wow. This here is the analog to digital converter. We need to solder these pins onto that. We don't need all of them. The only ones we need are VCC, which basically is plus, ground, which is minus, and SCL, SCA, which basically is where we will send the data to this guy. So yeah, we need to solder that on. The other part is the GPS. So the GPS, as you can see, also has VCC, which is plus. On the other end, it has ground, which is minus, and then it has receive and transmit. So they need these lines, and plus and minus will go into the breadboard. Where's the breadboard? Here it is. So it will create power on the plus and minus here. So we would want to stick this in here and this in there. That's correct. Like this, plus and minus. That means we will cut these off and then solder them on the plus and minus over there. That's one part. And the other is for the signal, so the middle two. We want these far ends to connect on any of these pins of the ESP32, the microcontroller. So we will cut these off and we will solder them into these middle two positions. That's it, that's all the soldering. I also suck at it, you might too, but it's easy to learn and to retry. So make sure you try with your cheapest one first. This is probably pretty cheap. You probably ordered two because they usually come in two. So play around with one, look up some YouTube tutorials, and then yeah, good luck. As for soldering, I use one of those guys. So you can just put the whole thing in there so it's connected the way it should. And then soldering station, soldering iron, and then you just go at it, one drop per item. And if it doesn't work, just remove it and do it again until everything is dropped. So here's the GPS. I kind of protected with some tape, otherwise these things can go loose quite easily and they have to solder again. So yeah, just protect that a little bit. This is the antenna that needs to be plugged into that thingy there. That thingy there. This is the controller. So solders are really amateuristic. Look at this. It's not beautiful, but hopefully it works. Let's find out. And now it's time to connect these guys. This one. All of that stuff onto a breadboard for the power. So the power rail. So all the plus and minus go in here. And then all the signals go in here. So here we have, what do you have? A1, A0, A2, A3. So that's where the analog signals go in. And then this one goes in here. GPS goes in there. That's kind of it. So let's give it a shot. This is what it looks like when everything is connected. One big mess. So let's debug the mess. This is the mother, the ESP32. We will connect this to ultimately a power bank, but for now it will be connected to the computer because we first need to load the software on there. This one has direct connections here to the GPS, right? With the GPS antenna. GPS goes into here. This one is also directly connected to the analog digital converter. The analog digital converter, A0, A1 and A2, are connected to this TDS, to this TDS, that TDS and the turbidity. The water temperature goes here, also on this one directly. So that's everything that's here. This outputs power. That power goes into that power rail. That's basically those plus and minus lines. All the power for all these separate devices all go into that power rail. So when we put power on this guy through USB, zoop, it powers the board, the breadboard. And the breadboard powers all the devices. All the devices have a data connection, and a data connection all go into the analog digital, right? Except for temperature, that one goes directly. This is all documented on the website, so take a look at those steps and then just give it a shot. What sometimes can go wrong is you fucked up with soldering, right? Then it doesn't make a good connection and you don't get data. What can happen is that there's maybe some power connection is not fully set up correctly. What can also happen is that you switched polarity from either these data guys, right? Transmit, receive, these are easy to switch around. Watch out with plus or minus for power, right? If you put power onto a signal, I don't think that's a very good idea. But signal, receive, transmit shouldn't be that much of a problem. And that's basically it. So there you have it, the whole thing. Oh yeah, let's connect it, let's connect it. Let's put some power on it. Power. Okay, so this one will start blinking if it gets a fix, but it won't get a fix because I'm inside. And that's it, then it's ready to go. Next step is to check out the Git repository for the software, load it in the Arduino IDE, and then push the software onto this guy, and then we can do the calibration. So now you have the board, you have the holes in the board, you have the sensors all drilled through and they're ready to go. They're in the basket or in the container. You connected everything, perfecto. You powered it up, lights are flashing everywhere. So what you need to do now is follow the instructions on the website. And that basically is go to GitHub, clone the repository, fire up your Arduino IDE, point it to the SeaSense logger start. There's an INO file, INO. And from there you add a device configuration. It's a file. And some secrets, your Wi-Fi, etc. And then you build the whole thing after you selected the right board. So the right board is ESP32 dev. The whole thing builds, and then you get stuff like this. Oh, cool. So I'll pause it for a bit. Basically what it says is that there is a timestamp. This is an epoch. This is the date timestamp. This is LUT. This is long. This is the quality of the HDOP, quality of the GPS. Turbidity 100 because it's fully see-through now. This is TDS. This is the EC. It's all uncalibrated now. This is the temperature 20. And these are some BME to 280, which is for surface temperature, etc. That's not connected, so it's not a number. So basically it's working, right? And then it wakes up and it goes to sleep. It wakes up, it goes to sleep, because every 5 seconds it wants to create a measurement. Everything is configurable. Yeah, I'll explain this in more detail later. But next up is calibration. That's important, because calibration yeah, tells us if we have a good reading. So next up is calibration. Calibration is all about making sure that what you measure, so you're measuring voltages, right? You measure voltage for a specific sensor, that the voltage value is the same. No. So let's talk about calibration. Calibration, extremely important. Ultimately, we want to make sure that when you do a measurement now, or you do a measurement in a year from now, or with another device, that if they do the measurement in the same place at the same time, they will get the same reading. There will always be some difference, but basically you want to make sure that it's the same. And how do you do that? Well, you take a calibration measurement in a known substance. So we have substances, for instance, distilled water. So distilled water has zero electrical conductivity, or almost none. So when we do a measurement and we get a certain voltage, that's our base voltage. So that's what we will fill into the device _config.h, which is basically your configuration file of your device. There's a section for calibration for each sensor. So what you write there, and it's pre-filled already, so you have a date at a certain timestamp. You measured a certain value, right? So the value is, for instance, 1413 microsiemens per centimeter. It's kind of a solution that you can, is that visible? It's a solution that you can purchase online. And the other one is, for instance, distilled water. So yeah, what you do is you restart. So there's a button called reset. When you click that, you go into boot mode. And in that boot mode, you have the first 5 seconds after boot. You can type calibrate. It also says so in the serial monitor of Arduino. So yeah, when you type calibrate, maybe we can just do it, that's easiest. So I just hit the thing. Now I have 5 seconds and I'm already too late, so calibrate. So I've typed calibrate there, hope you can read it. And if I do it again, I can type enter, and then it goes into calibration mode. So it says, okay, starting a 30-second calibration measurement session. Make sure to immerse the EC and TDS sensors in either demineralized water or 1413 microsiemens water. Take the readings and update certain values, then rebuild with the calibrated values. Oh, that's basically, it says what you gotta do, right? So now it's calibrating, so it takes hundreds of measurements, so to make sure that it's all the same, and then it says, okay, 255 measurements. Oh, wait 1 sec, pause, scroll back. 255 measures, the average TDS voltage is 0.0062 volt, average EC voltage is 0.0089 volt. Well, then depending on what you put in, right? Did you put this solution or did you put this solution? You will update your reading. I hope this made any sense, but yeah, that's the idea. Basically, you're configuring your specific devices so that when they measure a value, that it's correct. So, new feature. Look at that. Look at that, look at that, look at that, because we have a flag. My God, now it's like a proper boat. I say, ship it.